So again, gave you 30 degrees. Try to find the other 9 angles. Okay, remind you that that's the case. Probably take that test. If I do get a test on Thursday, probably not going to go. Okay. Especially with the lower vehicles. Before doing it all. Friday. All right, let's get this started. There's probably 2 angles that we could get started. So if I know that this is a 30-degree angle, there's really 2 angles that we could go. So there's different routes we can now take here. There's 2 different things we could start with. Anybody think they can give me another angle, knowing that that's 30? How could we get this at least started? Because once we get one started, then that hopefully knocks out some more. Anybody got one they can share here? That up. Does she? Okay. Alexis, what do you think? Good. So Alexis just said that angle 1 is 60. And how did you know that, Alexis? Perfect. So you probably couldn't hear it at home. She said it perfectly, though, that this is a 90-degree angle. The reason we know it's a 90-degree angle is we are told that right here, all of our angles are right angles. So she said since that's a 90-degree angle, she took the 90 that she knew the whole angle was, subtracted the 30 that we had labeled, left 60 degrees for angle number 1. All right, good. Did anybody start with a different angle based off of 30? Dahlia, you had your hand up. Was that the same thing you did, or did you go somewhere else to start? Okay. Let me let my spinner. There it goes. Okay, now Word is working again. And then it just jumped on me. This way. All right, give me a second here. All right. So you're saying that 8 and 9 are vertical angles? Oh, I see. So you put 9 right here? Okay. What the? It just all disappeared on me. Mr. Kubas, I almost said a really bad word. No, there it is. Okay. So what she's saying is those are vertical angles. I'm not going to touch anything. So she put 9 here, and she knew that whatever that angle there is going to be the same as angle 8. Okay. So that's good. So if we can figure out what this angle is, that's got to be the same as our angle 9. Those are equivalent to each other. All right, Jake, what do you thought? What are your thoughts? Good. Because what? You're very warm. All right, so what Jake gave me, this is the one that we haven't been seeing particularly well. These are parallel lines because a rectangle is a parallelogram. And we have then, in terms of what we've been quizzed on already, is a transversal right here. So what he just said is, doesn't angle 4 have to be 30 degrees? And he is correct, because these are on opposite sides of the transversal, right? This 30-degree angle down here and this angle right here that we're defining, opposite sides of the transversal, but they're also inside of the parallel lines. So these are alternate interior, Jake, alternate interior angle, and then he said those are congruent. So that's got to be 30 degrees also, all right? Then you can use either Jake's or Alexis's logic to figure out what number 5 is, right? Because what Alexis would have done for number 5, if we knew this was 30, doesn't this overall angle have to be 90? So we could do 90 minus 30. So that would make angle 5 60 degrees as well. Or we can use Jake's thinking. Isn't this 60-degree angle down here that we now know? So this yellow angle, isn't this angle an alternate interior angle to this angle? So the yellows are also alternate interior angles. Either route is 60 degrees for angle number 5. All right, good for both. All right, so now that gets us started. That gets us some things done here. Now we need to work our way and figure out some other angles. Anybody get us started on any others? Dahlia? Oh, I see what you're saying. Okay, this isn't the degree measure. That's just our 9th angle. Now I get what you were saying before. Yeah. Okay, so I misinterpreted what you had said, so I didn't. So this is angle number 9. So if we were to list all of these, we have angle 1, 2, 3, 4, 5, 6, 7, 8, 9. So those aren't the degree measure. Those are the number of angles that we want. All right, now it makes sense. But you can do what you did also. All right, anybody else got something? This one now is a little trickier. All right, let's go back to one of our parallelogram properties. There's probably a few different ways. So let's go to our parallelogram properties, where it says, since we're dealing with a rectangle, all these parallelograms are going to be the same, or same properties. And we have this here. The diagonals bisect each other. So diagonals bisect each other. And then notice how the diagonals are also congruent. So in a rectangle, the diagonals are congruent and they're going to bisect each other. So let's go back to this. So our diagonals are congruent and they're going to bisect each other. So let me get this up. Hopefully it doesn't mess with me here. This diagonal is congruent to this diagonal and they bisect each other. This is a midpoint. So if they're the same length, both of them, and they both cut each other in half, what that means is all 4 of these guys are congruent. So mark all 4 of those segments congruent. And then what I'm going to do, let me do this in blue down here. I'm going to draw in this triangle overall. Don't we have what we call an isosceles triangle? If you look at my blue triangle there that I have shaded in, aren't 2 of the sides, this side and this side, congruent? So again, old idea, just another layer of things that we have to remember. In an isosceles triangle, in any triangle really, if we have 2 congruent sides, then the angles that are opposite of those 2 sides also have to be congruent. So since this opposite side we know is 30, then that means the opposite side of this one must also be 30 degrees. Then from there, we can start knocking out a lot of these things, really. Now we should definitely be able to finish this off pretty quickly because we can use Alexis's logic down here. If this is a 90-degree angle, then this has to be 60 degrees. Keep in mind up here, like, isn't this an isosceles triangle as well? So didn't these opposite angles have to be the same? They just ended up being the same. So that's a good thing. If we use Jake's logic, here is this angle, its alternate interior angle is angle 3. So angle 3 would have to be a 30-degree angle. And then now Alexis's or Jake's thought gives us angle 2 to be 60. And then real quick, find 8 and 9, because my guess is the majority of us hadn't gotten that far yet. Now find 8 and 9. See if you remember how we would find 8 and 9. So I think at this point we probably hopefully know how to get 8 and 9, but go ahead and do that. Let me do this again. All right. Anybody come up with angle 8? What do we think angle 8 would need to be? Paige, what do you think? Good. Paige said it would have to be 120. How'd you do that, Paige? Good. So she took 30 and 30. She told me to do 30 plus 30. That's 60. And then she knew the full triangle has to be 180. So she took that 60 and subtracted it away from 60. That left 120 degrees for this angle. Now, angle 9, there's a couple different routes you could do for angle 9 now. One route, my guess is this is probably what most of us did here. Don't we also have a triangle over here? So we could use Paige's thought process that we have 60 and 60. So then whatever remains of 180 would have to be angle 9. If we just look at that yellow triangle, perfectly valid, right? 100% good. The other route we could take is, isn't this a straight line right here? And doesn't a straight line have to also add up to be 180 degrees? So if this is a 120 degree angle, there would be 60 degrees left over right here. Or just do what Paige did. 60 and 60 is 120. Subtract that away from 180. Either way, you're going to get a 60-degree angle right there. Okay. All right. Good. It's good to think. It's good to kind of have to go through those processes and see what we can figure out. All right. So the last one is what we call a trapezoid, and we haven't talked about this just yet. So come back up to these. I think we went through squares yesterday. So go down to where it says a kite. Yesterday we drew in that little, so if you have this real quick, go to the page where I told you to draw in your little flow chart, that blank page. And at the top we had what was called a quadrilateral. And then you should right now have in our parallelogram. So this is our parallelogram. And then we had a bunch of things beyond this. In a parallelogram, so two pairs of opposite sides are congruent. We also have something called a kite. All right, you can kind of see what a kite looks like. Do my best to draw this in. Two pairs, I should say parallel. Here, no pairs are parallel. So not every quadrilateral that we will deal with or see ever is going to be a parallelogram. We also have what can be called a kite. So if we go to the properties of a kite, this says two disjoint pair of consecutive sides are congruent. The word disjoint is weird. What that simply means is if I look at this side right here, doesn't that side have two consecutive sides? This side is consecutive to it. This side is consecutive to it. Notice how that yellow one is not congruent to both consecutive sides. It's only congruent to one or the other. And in this case, it's congruent to just this guy right here. That's what it means to be disjoint consecutive sides. Not both of them, it's only one. And then if you notice, this side here has two consecutive sides, the blue side and this side, but it's these two black consecutive sides that are congruent. So that's what that simply means, all right? And it's kind of, you can just tell that with the eye test. Number 2, your diagonals are perpendicular, so that just says they meet at 90-degree angles. One of the diagonals is a perpendicular bisector of the other. So notice how this segment here and this segment here end up being congruent. We also are perpendicular. So the long one is a perpendicular bisector of the short one. One of the diagonals bisects a pair of opposite angles. So look at these opposite angles right here. These opposite angles get bisected by that long diagonal. And then it says one pair of opposite sides are congruent. The ones that I currently have highlighted, again, if you just kind of use the eye test, those should not look congruent. The two opposite angles that end up being congruent is this angle up here and this angle down here. All right. To be perfectly honest, I'm not going to give you a ton of kite stuff, but trapezoids we probably will deal with a little bit more. So now go to the next one, and this is what that last question is going to cover. So in a trapezoid, what a trapezoid has, let me go to our flow charts. Let me throw this. This is a third option. A trapezoid has only one pair of parallel sides. One pair of parallel sides. So one pair, no pair, two pair. So this is what we call a trapezoid. This is specifically an isosceles trapezoid. What an isosceles trapezoid is the legs are congruent. So if we look at these two guys here, the legs are going to be congruent. That's what the word isosceles means, similar to an isosceles triangle. The bases, here are your parallel sides, so mark these two guys as parallel. All right, TR and PA are the parallel sides. The parallel sides are always our bases. That's how we can differentiate between bases and legs. Those are your parallel sides. The lower base angles are congruent, so that means here's our lower base angle. Here's the other lower base angle. Those are congruent to each other. And then the upper base angles. So this angle up here will be congruent to this angle here. They're not congruent to each other. So uppers are congruent, lowers are congruent. Number 5, the diagonals are congruent. So those dotted lines that I have drawn in there connecting our vertices, the diagonals are congruent. And then it says any lower base angle, so that's this angle here, is supplementary to the upper base angles. So the yellow and the blue angles should add up to be 180 degrees. All right. So again, a lot more stuff to get memorized. When we get to a quiz/test next week on all of this, have these things out. All right. It's a year where you can use your notes. So have all of these properties in front of you so that if I give you a problem like number 3, we can just reference the properties to answer these questions. So go to number 3 and see what you think. I'm giving you, that's an isosceles trapezoid. You're going to solve for x, and then you're going to find the lengths of PS and RS. And then the length of A to T is 13. All right, if you are stuck, let me give you the big hint. So if I show the properties again, here is the hint that you're going to need, or the property that we want to be referencing for this problem. So use this idea that I am shading right now. That's the property that we would want to look at and be like, oh, okay, that's what I'm going to use to tackle this problem. All right, and let's see what we got. So the one that I highlighted, if you just went back and look at the listed properties that I have that I highlighted this one where it says your diagonals are congruent. So that means that this length here from PR to TA, those are congruent. So the length of TR is congruent to the length of PA. All right. Wait, did I label that wrong? TA. Sorry. Well, look at what you were then given. Don't we know that the length of A to T or TA, isn't that 13? So we know that. So that goes from here to here. This is 13. Doesn't that have to be the same length as this full length right here? And to go the entire length of T to, why am I labeling these wrong? This is PR. So to go the full length from P to R, neither one of those gets us the full way. But if we took the X plus 5, that gives us this interval, and then add that to the remaining length, the 2X minus a 1, that then would have to equal 13 as well. All right, so that would be our equation. And then we can solve that real quick. So 3x, combine your like terms, 5 and a negative 1 is 4. Subtract the 4 over, so we get 3x equal a 9. And then what we should then end up with dividing by 3 is your x is a 3. That's only part of our answer. So we have x, that's good. But this also asks us to find P to S, the length of P to S. P to S was x plus a 5. And we now know that our x is a 3. So P to S has a length of 8. And then we want R to S. These are not congruent. There are some parallelograms that the diagonals bisect each other. It's where we would just say it's an 8. This is not one of them. Or it's not even parallelogram. Some quadrilaterals where they are. So this is now RS. RX is 2x minus a 1. So let your x be a 3. And we should get 6 minus a 1. So that RS is 5. All right. Lots of stuff to memorize. Have the notes in front of you. Have all those properties written down. Because as you then look, if we go to what is then the homework, so this is going to be 5.8 where it says the homework 5.8. Notice how you have a parallelogram. Then I'm going to give you a rectangle. Then you're going to get a rhombus. Then you're going to get a square. Then we get all these brain teasers here. Even if I were to sit down and key this up and do this, I would probably put these properties right in front of me, especially as we start getting to like the rhombuses. And there's a lot of these unique little properties here that is almost impossible to get fully memorized and access. So you just want to be able to look at your notes. What are we looking at? And then be able to answer these questions. Okay. What time we got? 4 minutes. Yeah, we'll do this one real quick. We'll at least get it started. But that's your homework. You're going to do 1 through whatever that was, 24-ish. These next 2 pages is what our homework is. It's on Canvas right now. It's ready to get uploaded. But what I'm talking about is in terms of having your notes. So when you see that this is a parallelogram, so if I were you, what I would then do is think, all right, if this is a parallelogram, what am I given to work with? I'm given this angle here, and I'm given this angle here. So when I look at my properties, I'm going to look at the properties that deal with angles. So if I now scan back up, hopefully this thing doesn't die on me in the last 4 minutes, to all of our properties of parallelograms, this is a side. So for this problem, our first bullet doesn't really do us any good because it's talking about sides. So I'm not going to worry about that one. The second one also talks about a side. So I'm not really going to worry about that one. If you look at number 4 talks about diagonals. That's no good for the problem we are looking at. The one that deals with angles is this one here and this one here. So look at your problem number 1 and identify, are we looking at opposite angles or are we looking at consecutive angles? So if we revisit that problem and we look at those two angles, what we would hopefully realize that, you can get there, the two angles that you were given to work with in this first problem set are opposite angles. And what that property said is that opposite angles are congruent. So with knowing that, that's how we can set up our equation. If they are congruent, that means they should have the same degree measure. So we set them equal to each other. If they were consecutive angles, then they're supplementary. You would add them and set them equal to 180. All right, so then real quick, solve this guy. So you're going to get 38 equal 3x minus a 4. Oh boy, here we go again. So 3x should equal 42. So when you solve this, sorry, this is a little messy, x is 14. Then to find angle ADC, we're just going to take this 14, come over here to angle ADC, throw the 14 in for your x. So 3 times 14 plus 38 is 42 plus 38. What you would find is that angle D, or angle ADC, should end up being 80 degrees when we plug that in. All right, so I now know that this is an 80-degree angle. But the last angle, we don't have any markings, right? BAD is this angle up here. So that was the other angle property. The other one, these are now consecutive angles. Consecutive angles are supplementary. So if I know that this is an 80-degree angle, its supplement would have to be 100 degrees. So that's how we can then kind of work our way around that problem. Okay? So a bunch of these to do now. Let's see how this goes. Be patient. Some of this can be pretty tricky. Okay? You'll do all of them. Yeah. Yep. Okay. Any questions? You got a minute? Hang out. If not, we'll see you tomorrow. Okay. Have a good night. Yes, ma'am. Yeah, go ahead. Yep. Bye, Alexis. Have a good day. Bye, Paige. So what we did, Dahlia, if I can change this. Once we know that x is 14, see, Jake, I'm going to take this and I'm going to plug it in for this x. So I'm going to do 3 times 14. I'm going to add 38. 3 times 14 should be 42. And then I'm going to add 38. That's going to give me 80 degrees. So that's what this expression right here gives you. So now look at what angle ADC is. I'm going to go from A to D to C. That's the angle I'm looking for. This is ADC.